All right, good day and welcome back to Everything Mathematics. And today, Monday, we're going to continue our series, our part two of three videos in which we discuss the three various ways to calculate the area of a triangle. On Friday, which was part one, where we started looking at the area of a triangle, we look at how to use, or when do we use rather, half base times height. And we established that once we are given the height and the base, or once we could find the height or the base of any given triangle, we could calculate the area by using half base by height. Today, however, we're going to look at the conditions, of course, as to when do we use Heron's formula or understand the conditions for when Heron's formula is applicable. And last but not least, we're going to look at how to use Heron's formula to calculate the area of a triangle. We're going to do several examples and hopefully after that we will have this covered. So, when can we use Heron's formula? Simple. We can use Heron's formula to calculate the area of a triangle when all three sides of a given triangle is given, or of course, if all three sides could be founded or can be found. Remember, there is always this element of algebra in mathematics. So even if something is not given, but let's say you are asked to do it, then that means there's a way to find out. Good. So it is possible that you get a triangle with only two sides given, but there is a possibility to find the third one in order to find the area. So that's what I'm saying here, when given or if otherwise when it can be found. So here is basically Heron's formula. And you might wonder maybe why, I don't know if you may be wondering, why is it called Heron's formula? And I think it's pretty straightforward. Probably somebody by the name of Heron would have founded this formula and they just name it after them, as is common with many discoveries, right? So if you discover something and you have a cool name, oftentimes you just name it after yourself. Or if not, you name it after something that you like, even if it doesn't make sense. But that's just, you have the right to do that because it's you. Just like making a child. If you make a child, it's up to you to name it how you want, right? It's pretty much part of your creation. There is no objection as to how you want to name it or what you want to name it. So same thing here with this formula. The person that would have made this formula's name was Heron. And when he discovered this, he decided to name the formula after himself. And what does this formula simply say is that you have to firstly find the S, which is known as a semi-perimeter. And to find that, you have to add all three sides of the triangle. That is why the sides are needed for this formula to work. You add all three sides of the triangle and you divide that by 2. And then you follow this little procedure over here. The square root of S minus A, S minus B, S minus C. It's really that straightforward. And the beauty about it nowadays is like if you're doing this for CXC, C6 students, I guarantee you, you don't have to memorize this formula unlike back in a lot of our older days or some of our older ones days, because today this formula is actually presented to you in the formula sheet. So there's no need to commit this to memory. All you need to be able to do is apply it. You have to know how to use it, like how to get the S, or to what is A, what is B, what is C, and that's really easy to put together. So let's see if we could do some examples. I think I have 3 in this video. Let's see how fast we could do them. So here we have an triangle. It's a scaling triangle because all three sides are different. But what you need to understand is that we are given all three sides. And because of that simple fact, then we know that we can use Heron's formula. In a case like this, definitely half base times height cannot work because we do not have the vertical height. So there's no way that half base times height could work here. So how do we use Heron's formula again? Firstly, we have to find S. What I like to do, and I advise students to do the same, just label your shape. So you could make A, B, C. And this is not standard. If you want the 9 to be A, the 5 to be B, and the 8 to be C, that's all well and fine. But the reason why I recommend this is so that at least when you start your question, you have a standard as to who you will be referring to as A, who you will be referring to as B, and who you will be referring to as C. As I said, that is not a must, but that is totally up to you so that you yourself don't get sidetracked and lost, right? So let's find the semi-perimeter. So we have S, and we remember from the previous slide, the semi-perimeter is A plus B plus C divided by 2, in which case we have 8 plus 9 plus 5 all divided by 2. And if I solve this here, I'm supposed to be getting what? 8 plus 9, that is 17, and 17 plus 5, that is 22. My math serves me well. So that's 22 over 2, which is equal to 11 meters. So my semi-perimeter in this question is 11 meters. And now that we know S, we could go about and calculate our area. So for the area, remember we have to do, oh sorry, I put the A as if it's already outside of the square root. Our area of a triangle, let me put a little triangle there, is equal to the square root. I usually advise also to write the formula first before substituting. So S into S minus A into S minus B into S minus C. And from here on, we just substitute our values and we just perform our arithmetic. So we know that S is 11, so that will be 11 on the outside. And then we have S minus A. And remember, I labeled my A, so my A will be referring to the 8. So that will be 11 minus 8. Then S minus B, remember my B was labeled as 9, so 11 minus 9. And then S minus C, and my C, I labeled it as 5. So that will be 11 minus 5. And again, you don't have to have it in the same order that I have it, as long as you have everybody including. And this is the same as, simplifying a little here now, 11 by 11 minus 8, that's supposed to give me 3, so I have 3 here. Then 11 minus 9, that's supposed to give me 2. And then we have 11 minus, oh, the 2 disappearing, 2, and 11 minus 5, that's supposed to give me 6. And remember the bracket here all saying that we have to multiply. So if I multiply all this here, let's see, I think I could still do this without a calculator. So 3 times 2, that is 9, so what I'm saying there. 3 times 2, that is 6. And 6 times 6 is 36, and 36 times 11, 36 times 11, according to my calculator, I am getting 396. I'll show in my units here. Sometimes we forget it, and I usually leave it out coming down because it's a lot of writing and sometimes it takes a lot of space. So 396 meters, the square root of that will be the area. So if I find the square root of that, 396, according to my calculator, you will get approximately, the area here will be approximately 19 point, let's say 9 meters squared, and this is in respect to 1 decimal place. Yeah, and that is it. Well, the question didn't ask us for the perimeter, but we actually had to find the perimeter along the way. The perimeter would have been 22 meters if they had asked us to calculate the perimeter, right? Let's go to the next one. And here we have another example. Here we have it in centimeters, and again, as usual, I will label. Let me just change around my label so you'll appreciate that it's not always A, B, C on from that side. So let me put this one as A, let me put this one as B, let me put this one as C. Good. And then I go about finding my semi-perimeter. So that will be my S. And remember, to calculate our S, we just add all our sides and we divide by 2. So that will be 12 plus 10 plus 6. And I didn't respect the ABC, but it doesn't matter because all I know is that I'm adding all 3 sides and dividing by 2. And let's see, what do I have here? So 12 plus 10, that's 22. 22 plus 8 is 28. So that is 28 divided by 2. And if my math serves me well, that will give me 14 meters. No, I lied. This one is centimeters. So 14 centimeters. And then I apply the Heron's formula. I finish with Heron's formula. So again, the area of the triangle would be equal to, and the more you do it, to be honest, the formula sticks with you. That reminds me of when I learned the quadratic formula. When I learned the quadratic formula, at first it seemed like the most interesting thing to memorize, but the more you do it, it just sticks with you. So right now, Heron's formula is like by the way thing, you know. And it's kind of sad. In a way, I call it sad because today you no longer have to learn these interesting mathematical equations. It's just given to you and you just need to know to use it. But there was a pride in being able to, you know, recall these formulas off your head back in those days. That was like a big time maths person, you know. You could recall the quadratic formula. You could recall the what? Heron's formula. You could recall the trigonometric ratios. Yeah, those things used to be cool as mathematics students back in the days. I don't know if there's any significance in those things today. Right, so again, remember, I label my A as 12, I label my B as 6, and I label my C as 10. So I just have to remember which is which. And again, as I said, it doesn't matter as long as you include everybody. It doesn't have to be A first, B first, because by now we should know that multiplication is commutative. So it doesn't matter how you choose to multiply it, you will end up getting the same thing. 14 minus 6, that is what? 7 or 8? I think that's 8. And 14 minus 4, that is 10. Sorry. 14 minus 10, that is 4. It seems that we'll get a big number here, one that I'm feel lazy to work out mentally, so let me use my calculator. So 14 times 2 times 8 times 4, that gives me 896. And again, I'll throw in my centimeter units here. And if I just square root that, if I square root my answer will approximately be 29.9 cm squared, and this is of course round off to 1 decimal place. Yeah, so that's a second example using Heron's formula. And let's try a third and last one. And this one is in millimeters, so our units are a bit bigger. But again, the concept is the same. The concept is the same across the board. So here again, let me put this one here as A. I'll refer to the 50 millimeters as B, and I'll refer to the 30 millimeters as C. And here I go. So I have my S, my semi-perimeter, which should be in this case 50 plus 30 plus, oh, that worked out nice, 20, all divided by 2. One of the things you could do too, by the way, I mean, it's not obligatory, but it's not a must. But one of the things you could do, if you find you're getting too much of a big numbers in a unit, you could convert it to another unit, and your life will be made a lot easier, perhaps. So here I see it's in millimeters. And if you wanted it to convert it to centimeters, let's say, you'll be working with a lot more for smaller numbers, which is not a bad thing. Oh, but herein lies the problem. This one may not, this one will not work. So this is one of the conditions that, and yeah, I guess it's because it's a right triangle. So this is unfortunate, but no, this question would not work. And here why, I will tell you why. Matter of fact, maybe good thing we bounce up with this one. And that's okay, I make up this question. So in the future, surely you will not end up with an example like this. But let me appreciate that this happened. Let me show you why this would not work. Because I pick it up as I get the semi-perimeter equal to 50. So here what? If you go to continue, you would have the area, of course, and you state your area. And you have S into S minus A, common A. The square root disappear. Right, A minus A, S minus B, and S minus C. And probably you're still wondering why it wouldn't work. Why wouldn't it work? Let's see this. Why wouldn't it work? And then we have the square root of, so S is 50, so we have 50. And then we have 50 minus our A, we have A as 20. Then we have 50 minus B, and we have our B as 50, and there is a problem. And then we have 50 minus 30. And I guess that's the disadvantage of making up 4 triangles, because this is actually a triangular triangle, so it's supposed to be 3, 4, 5. I put 20 instead of 4, but that's okay. So here what is happening? We will end up with the square root of a 0 here, and the square root of 0 will end up being 0. Everything multiplied by 0 is 0. So okay, let me make a long story short. So when you multiply everything inside here, you will end up with an answer of 0. And this is definitely a maths error, because it is impossible for the area of a shape, the shaded region that I'm shading here, it is impossible for that region there to have a number represented as 0. So, and I know why the problem here is. The problem here is simply because the semi-perimeter is the same as with the length of one of the sides. So when you subtract one from the other, you end up getting 0. You will get 0 inside here. 50 minus 50, that will give you 0. And by default, everything multiplied by 0 will end up being 0, and the square root of 0 is still 0. And well, it's not an error. I guess in real life, maybe you could have a calculation like that, and that will just lead you to know that something else is wrong in your measurements when you either went and measure the land or the property or the area of wherever you're trying to find out. So this is cool to know, and I'm kind of glad I guess it came up. It wasn't planned, but it's something that you need to know. For CSEC, I highly doubt that you will get a question where, of course, the area cannot be calculated. But in higher levels of maths, this is not anything new. This is not anything strange. It should not be strange to you that as you go up higher levels in maths, that sometimes the answer comes out to be something like undefined or undeterminate, or it cannot be spelled out. You know, all that is well and fine. That's honestly well and fine. So yes, I'm glad this come up, honestly, although I must say this wasn't the plan, but everything for a reason. So that will bring us to the end of today's video. So as always, again, like, share, and subscribe if you haven't subscribed as yet. Leave a comment in the comment section and turn on that notification, that red bell by the subscribe button, so that you can continue getting videos like this every day when they're released. Until then, you take care, and this was Everything Mathematics. Cheers.